Okay, question 9. A lot of people don't like these questions because they're so wordy. The things that you've got to remember, the things that are given in your formula booklet, is that a plus n minus 1d, that's how to find any term in a sequence. And the other one, Sn equals a half n 2a plus n minus 1d, that's how to find the sum of a sequence. So we've got on John's 10th birthday, he received the first of an annual birthday gifts of money from his uncle. The first gift was £60, so the first thing I'm going to write down is that A equals 60. I mean, the wordy questions are tricky, but if you sort of break them down and just write down the information as and when you get it, it tends to help. And on each subsequent birthday, the gift was £15 more than the year before, so therefore the difference each year is going to be 15. So that immediately after his 12th birthday, the total of these gifts was 225. Now, you don't need to use the sum, because you've got, and I'd probably write this down as the 10th birthday, he got 60. The 11th, he got 75. On the 12th birthday, he's got 90. So you add those three together, and that's going to be 225. So yeah. You just need to add those three together. If you want, you could do the sum, but it's only worth 1 mark, so you've only got to do like 1 minute's worth of work. So that is more than fine. Find the amount that John received from his uncle as a birthday gift on his 18th birthday. So the trickiest thing about this one is that you see that 10 is the first one, then 18, so you think that n is 8. If you have a look at the 10th is the first one, 11th is the second one, 12th is the third one, so this number here is one less. So if we've got 18th, that's going to be n as 9, so it's going to be the 9th one. So what we need to do is a plus n minus 1 plus a d, so it's going to be 60 plus 9 take away 1, lots of 15, so that's 60 plus 8 times 15. Well, 10 8s are 80, 5 8s are 40, so that's going to be 120. So 60 plus 120 equals £180. Find the total of these birthday gifts that John had received from his uncle up to and including his 21st birthday. So again, the 21st is going to be the 12th. Because this number here is always one less than the term, so therefore if it's 1, therefore it go up by 1, so it's going to be 2, so it's going to be the 12th term. So then we've got to use this thing here. Now, we haven't got much space on this screen, so if we then start this again here, so we had that was 180. So it's the 12th term, so n equals 12. We had a as 60 and we had d as 15. So it's going to be a half times by 12. 2a, so that's going to be 120 plus 11, or 12 minus 1, times by 15. So 11 times 15 is 165, plus 120 is going to be 285, so it's going to be 6 times 285. So 285 times by 6. 6 5s are 30, 6 8s are 48, plus 3 is 51, 6 2s are 12, plus 5 is 17. So it's going to be 1,710. When John received any of these birthday gifts, the total amount that he had received for these gifts was 3,375. So show that n squared plus 7n equals 25 times 18. Okay, so we've got the key word here, which is a total. So let's work out the total then. So if we use this formula up here, which tells us the total, we don't know what n is, but we do know that a is 60 and we know that d is 15. So we know the total, 3,375, equals half n. 2a is 120, plus n minus 1 times by the difference, which we know is 15. Then we're going to try and multiply that out, simplify it, so it looks like this thing here. So, because we've got the half there, what it might be worth doing is timesing the other side by 2. So that's going to be 6,750 equals n 120 plus 15n minus 15. So 120 minus 15 is going to be 105. So it's going to be 6,750 equals 105n plus 15n squared. So if we divide through by 15, we're going to have n squared, and 15 goes into 105 7 times, plus 7n, which is kind of handy because that's what it is over there. If we divide this by 15, 6,750 divided by 15. 15 goes into 67 4 times with 7 remainder. 15 goes into 75 5 times with no remainder and doesn't go into 0 at all, so that equals 450. So 450 just so happens to be 25 times 18. So if you want, you could do 450 divided by 25. 25 goes into 45 once with 20 remainder. So 25 goes into 200 8 times. So we can say that n squared plus 7n equals 25 times by 18. And then finally, E. Find the value of n when he had received 3,375 in total, so determine John's age at this time. So we've got to find the value of n. So we've now got to solve to see what n is. If we go back to this thing here, we've got to solve n squared plus 7n minus 450 equals 0. Now it's only worth 2 marks, so we should be able to do this in 2 minutes quite comfortably. But factorising this isn't going to be easy. So you know it's going to be n and n. So we've got to find 2 numbers that multiply together to make 450. Now they've done this a few times. What we've learned from the previous question is that 25 times 18 is 450, and the difference between 25 and 18, of course, is 7n. It's going to be n plus 25, n minus 18. So our 2 solutions, n equals minus 25, and bear in mind that n is the number of years, that can't be right. N equals 18. So if n equals 18, then that means that's going to be the 18th one. And remember that this number here is always 1 more than the years, so therefore it's going to be the 7 on the end, so therefore John's going to be 27. And that's it. That's how to do that question.